Factor theorem says a polynomial f of x has x minus a as a factor if and only if f of a is equal to 0. And this theorem is going to be very similar to the remainder theorem. What it's basically saying is that if we have some function x divided by some function g, and we get a quotient of x, if this divides evenly, if g of x divides evenly into f of x, and we get some quotient and we don't get a remainder, so no remainder, then we can say that g of x is a factor of f of x. So it's like if we divide 2 into 10, because it divides evenly, 2 into 10 we get 5, then we can say that 2 is a factor of 10. But if we try to divide 2 into 11, it goes into it 5 times, 10, and we're left with a remainder of 1, so it did not divide into it evenly. So 2 is not a factor of 11. So the same sort of idea applies to functions. And here, the only difference we're saying is that instead of just some arbitrary form of g of x, although any function is technically, this is, in this form here, x minus a, it's in its simplest form. So instead of g of x, we write x minus a. So if we have f of x and we're dividing it by x minus a, it's going to equal some quotient of x, if it is a factor. If it's not a factor, then we will get some remainder. So if it's not a factor. And this idea that we can put in a and get 0 comes from here. So assuming that x minus a is a factor, we can do the same sort of thing that we did with our remainder theorem, where we multiply x minus a to the other side. So we get f of x is equal to x minus a times the quotient of x. And if we put in a into our function, f of a, we are going to get, I didn't mean to put x, I meant to put a. We're going to get a minus a times the quotient of x. And no matter what the quotient of x is, a minus a is always going to be 0. 0 times anything is 0. So no matter what, if x minus a being the corresponding factor, or the corresponding number for the factor, then x minus a is a factor. If f of a is equal to 0. And this has a lot of useful properties. One immediate use for it is we can factor higher order equations using this method, like cubic functions, quartic functions, quintic functions. If we are able to get a couple of zeros and then factor it out into a quadratic equation, then we can use the quadratic formula. So I have an example here. Let's say I have f of x is equal to 2x cubed minus x squared plus 2x minus 3. And actually this is a two-step deal. First I want to know, is x plus 3 a factor? And is x minus 1 a factor? So according to our factor theorem, if something in the form of x minus a is a factor, then f of a must equal 0. So a simple test to find out if this is a factor is just to put in minus 3 in for a, and then solve the equation and see if it's equal to 0. So let's do that. So we'll do this first. We'll do x plus 3 first. And we're looking for x, want to know if this is a factor. So a is equal to minus 3 in this instance. So we have, well, let's get our equation again. Okay, here's our equation. So if x plus 3 is a factor, then f of minus 3 must equal 0. So we have f of minus 3 is equal to 2 times minus 3 cubed minus 3 squared plus 2 times minus 3 minus 3. So let's go ahead and solve this. So minus 3 cubed, that's minus 3 times minus 3 times minus 3. So that's minus 27. Minus 27 times 2 is 54. Minus 54. So we have minus 54. Minus 3 squared is 9. So that's minus 9. Because we have the minus sign out here. And then we have 2 times minus 3. So this is minus 6. And then we have minus 3. And we can see that since they're all minuses, this is not equal to 0. Just write it like this. This is not equal to 0. So x minus 3, or x plus 3, I'm sorry, this is not a factor. But let's look up again, and we also want to know, is x minus 1 a factor? So we have x minus 1, and it's in the form of x minus a, so our a is equal to 1. And our equation is 2x cubed minus x squared plus 2x minus 3, so let's write that out again. 2x cubed minus x squared, and what else do we have? Oh yeah, plus 2x plus 3. It's 2x, no, minus 3. Yeah. So if this is a factor, then f of 1 must equal 0. So let's put in 1 for this equation. F of 1 is equal to 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. When we simplify this, we get 2, 1 squared minus 1 plus another 2 minus a 3. And we can see that 1 and minus 3 is minus 4, 2 and 2 is 4, so this is going to be equal to 0. So we can say that x minus 1 is a factor, which means it's going to divide evenly. It divides evenly into this, so we'll get no remainder. So what we're going to want to do, or actually, no, this leads me to my next part of the question is, how do we factor this further? So how do we factor this completely so it's in simplest possible form? So here we have x minus 1, and we know that x minus 1 is a factor. So now what we can do is use synthetic division to divide x minus 1 out and see what is our quotient. So let's set up a synthetic division problem. So our a is 1. Now let's set up our coefficients. Our coefficient for x cubed is 2. For x squared is minus 1. For x to the first is 2. And for our constant is minus 3. And again, we're going to see in this synthetic division problem that we are not going to get a remainder because it divides in evenly. So we bring down the 2. 1 times 2 is 2. Subtract that. We have 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. And we can see that minus 3 and positive 3 are going to give us 0. So we have no remainder. And that's exactly what we expected because it divides evenly because it's a factor. But now we're left with a quadratic function rather than a cubic function. This is our x squared. This is our x to the first power, and this is our constant. So our function, so we can say, here's our original function up here. Let's rewrite it. 2x cubed minus x squared plus 2x minus 3. And what we're saying is what we're going to do is write this in factored form now. So we know that, let's change colors, we know that x minus 1 is a factor, and then we now figured out this other factor. We get 2x squared plus x plus 3. And these two things are the same thing. If we multiply this back out, we will get this again. And we can factor this even more. What we can do is we can use our quadratic formula. And simplify this into x plus another a and x plus some b. I'm not going to do the quadratic formula, you guys all know how to do it, but this is how we would simplify a expression like this.